Hello children, let us continue the graphical representation of motion. In this session, we are going to find out the speed from the graph. How can we find it? Let us see it. Suppose an object is in uniform motion. As we know, for the uniform motion, the graph is plotted, that is, the distance time graph is plotted. This is the graph representing the object is in uniform motion, straight line. From this graph, we are going to find out the speed of the object. How can we find it? Since the object is uniform motion, the speed of the object is same at every point. To find the speed, let us take 2 points on this graph. 2 points anywhere. Suppose the points are, this is point A and this is point B. We can take 2 points anywhere on the line, anywhere on the graph. Now find out the position at point A. Let us take this is D1, and the time at point A. Let us take this is time T1. Then coming to the point B, here also it is the position D2 and the time is T. So these 2 points are taken and their corresponding positions and time are mentioned. Then just draw a parallel line from the lower point to the time axis, which meets this line at point C. Now we get a figure, that is ABC, a figure. Definitely this is the right angle triangle. This is right angled triangle, that is ABC. Right angled triangle ABC. And in this right angle triangle, here it is 90 degree. The side opposite to 90 degree, that is hypotenuse side. The other two angles are acute. Here we take, this is one of the angle. This is one of the angle. That angle is BAC. If we mention this as an angle, this is the angle made by the line, the graph with time axis, because here we drawn AC parallel to time axis. If these two lines are parallel, these two angles are also equal, their corresponding angle. So here if we take any point, here also we can take the point and join, the angle is formed. Then all the three angles are same because all are corresponding angle. But here we took only these 2 points. And if we take this triangle, we consider this as an angle. In this triangle, we take this as an angle. For this angle, the side BC is the opposite side. AB is the hypotenuse. The side opposite to this angle we considered is opposite side. So BC is opposite side. That can also be considered as perpendicular side. It is perpendicular. It is perpendicular. And the third side, this is AC. This is the base. This is base. Now, if we take the ratio of the perpendicular to the base, the ratio of perpendicular to the base, that is BC upon AC. This ratio in a triangle gives, the ratio of perpendicular to base gives the slope of this, slope of AB, slope of this line AB. So whenever we have the right angle triangle, in that case, if we mention any of the angle except this 90 degree, either this or this, for this angle we have the perpendicular and the base. The ratio of perpendicular to base is the slope. Now if we find the slope of this triangle, we have the measurement, distance measurement, time measurement for the point B, and for the point C also measurement, distance and time. Now if we want to find out the BC, the length of BC, it can be definitely taken as it is BC equal to D2 minus D1. For the point B, D2. For the point C, it is D1. The length is D2 minus D1. And coming for the AC, the value of AC, that is also equal to this length. And this length, here we can give any other symbol DE. Since this AC is drawn parallel to time axis, so AC is equal to this DE. Then DE can be written as this value. Let us take this point O. D can be written as OE minus OD. OE that is equal to T2, OD that is equal to T1. So DE equal to T2 minus T1. That is equal to slope of AB. Now you see the final position, this is the final position minus initial position. The length between the final position and the initial position, that gives the distance between them. So it is the distance between them. And the final time minus initial time, that gives the time between them, time interval between them. That is equal to slope. So as we know that the distance upon time, that is the speed. Distance upon time, that is equal to speed. So that speed is equal to slope of AB. Speed is equal to slope of AB. It means if we find the slope of this graph, that slope gives what? Speed of the object. Therefore, finally, in the conclusion, we can say the slope of dt graph, the slope of distance time graph, this is dt graph. The slope of distance time graph always gives the speed of object. That is the final conclusion from this graph. Whenever you have the distance time graph, if we find the slope gives the speed of object. So here one important conclusion has been obtained. Slope of the dt graph gives the speed. If the slope is greater, the speed is also greater. Then if we take, this is the motion of object, uniform motion of object, a single object. If we take the two objects, suppose two objects, two cars, A and B, car A and car B, they are moving along same direction, but their speed is different. They are starting from the same point, but their speed is different. If we plot the graph for these two objects, in the same graph, suppose for A we are getting this straight line. This is the motion of object for motion of object A, and this graph represents the motion of object B. Now from the graph we can say that we are getting straight line, so object A and B are in uniform motion. So from the dt graph, by finding the slope, we can find out the speed. So that means the speed of A and B can be calculated, but their speed is different. Their speed is different. Which object is traveling with the greater speed? That we can find out. Already I told the slope of the graph gives the speed. If the slope is greater, the speed is also greater. Here you can observe the graph and which graph has greater speed. For that, the slope is obtained by the ratio of sides. For that we took the angle. Here we are getting the angle. This is the angle made by graph A and graph B. Whatever be the graph which makes greater angle with the time axis, that will have the greater speed. So from the graph itself we can find the speed of A is greater than speed of B. This is the comparison of speed of different objects from the same graph. So this is all about the distance time graph. Then we will go to the velocity time graph. In the next session we will see the velocity time graph.